Okay, let's say Bismillah. Are you ready, Dr. Arif?
Yeah, inshallah.
Okay, Bismillah. Welcome everyone in the first webinar in the global data community. First, let me introduce what global data community is. Okay, just a second. This is our logo, the global data community. And the global data community is one of the Saudi data community chapters where we aim to improve the data, where we aim to improve the data knowledge in the community by inviting an expert and learn from their experience. This is some picture of our past meetups. And our golden sponsor are Masterworks and Munshaat, the Ka Center, and Sirin. This is our sponsor for 2020. And today, we would like to welcome our first guest in the global data community from United Kingdom, Dr. Arif. Dr. Arif Gosnanto is an associate professor in the Department of Statistics at University of Leeds at United Kingdom. Professor Arif, how are you?
Alhamdulillah, okay, yeah? Alhamdulillah.
Yeah. Nice to see you again.
Nice to see you again, yeah.
Just give me a second, let me change the view. Okay. Okay, Dr. Arif, just okay, Dr. Arif, you have a long experience in statistics and big data, and if we want to talk about your achievements and your experience, that will take more than one webinar. So let's say you are a statistician, and that's enough.
Yeah.
Professor Arif, do you need to go directly to the talk, or can I warm up with some couple of questions?
Yeah, sure, no problem. You can ask me some questions beforehand, yeah.
Yeah, because there is some questions they are in my mind. I want to ask it to you. One of them is that 2.9 million euro. That was the funding of your current project that you are working in right now. So can we know more about this project?
Yeah, well, this is a EU-funded project headed by Professor Janine Houwing Duistemat. She was the original proposal along with 9 different partners from 6 different countries. So in this project, we deal with different types of data, biological data. This includes glycomic data, genetic data, DNA methylation data, and other type of clinical information across different cohorts, we can call it, with the aim to investigate the concept of healthy aging. Yeah, so I don't know whether this is a concept that is well known in Saudi Arabia, but we have a concept of healthy aging here, where
the old people,
yeah, people go old to have age above 100 years old. Yeah.
oh,
So
okay. We called it in Arabic al-mu'ammirin.
Yes. So if someone live until 110, and some of them actually live until 120 years old. So what is so special about them? Is it because they have a certain genetic pattern for example, that is quite how should I say, unique or special, that give them a long life, etc. So this is basically the project. So there is this component of biological science as well as statistical science, big data analytics in it, but with regard to biological data.
Nice. Okay, can you tell us more about the data part in this project, specifically
Uh,
the data part?
the data is, for example, from twin studies. I don't know whether you are familiar with twin studies. So if you have a twin,
Yeah.
so if you have a twin, you share genetic code between the twins. Yeah, if the twins are monozygotic, then your genetic code will be the same. Yeah.
Okay.
If you are a dizygotic twin, then you share 50% of your genetic code, yeah, between the twins. So if we have a twin and the genetic code is the same, monozygotic twin, and one of them experience something like a disease or something, yeah, during aging, one of the twin may develop a disease, while the others uh, don't experience the disease. Yeah. So what could have caused it? Is it because of the genetic code? If it's genetic code, it's not really the case, because they share the same genetic code. So it must be something else. Yeah. So that's an example of where the type of investigation is done in this big project. This includes, for example, uh, idea where some individuals can live to 100 and 120 or 110 years old. And then we check their DNA methylation, for example. DNA methylation is something that will control the activity of a gene. Okay. So if every human being has, I don't know, almost 30,000 genes. So where the methylation level, which controls whether a particular some genes will be active or not, we investigate this as well, whether uh, they, they are affecting how some individuals live to 100 years old. Yeah, this also,
Which kind of
yeah.
statistical method that you are using in this experiment?
Oh, a lot, many.
Like
So, so
what's
this includes, I don't know, maybe you know about this principal component analysis.
you know?
Yeah, this also we involve as well uh, uh, Fisher test. We
Okay.
involve modeling, random effects modeling. Yeah, statistical modeling on random effects. Survival analysis with Cox proportional hazard or any parametric method.
Mhm.
So these are the type of methodology that are involved in in the project. Yeah.
Okay, since you are using the parametric methods, that means you have a big data
Yes, we have quite a big data for this.
in
I
this
think
project.
around 30,000 individuals or so. I forgot the exact number, but that's more or less the figure that we are dealing with. But it's not really strange anymore in research to have a big data. In the UK, we have what we call UK Biobank, where we have 500,000 individuals take volunteer to be a participant, and we take around 1,500 different variables about them. In addition to that, we also record about 1 million slips, 1 million variables, I think, if you see
Nice.
it from. So imagine if you have a table with 1 million columns and 500,000 rows. Yeah, that's the size of the data.
With 1 million variable.
Yeah.
Okay, this is a good one. I have a question in this area specifically. Since your general expertise is a big data and dealing with big data, lately I noticed there is many specialists who are in the field. When they are trying to build a model, they are using all variables that they have, uh, which is statistically wrong. Can you tell us why it's statistically wrong to use all variables that you have or too many variables
Well, it's not really
in
wrong
big
in the
data?
sense that in absolute sense. No, it just not necessarily recommended, because
Mhm.
what happened is that the information content in the data that would be informative, that would be predictive for the outcome, tend to be just only a subset of them. Do you understand? Yeah. So it's not all of them may be relevant. Usually, only a subset of them. So that's the challenge basically, because using all variables may not necessarily help us in the prediction or in the modeling.
Okay, statistically, what's the solution of this problem or this issue?
Well, the solution is, for some machine learning enthusiasts, they call it feature selection or variable selection. Now, there are 2 or 3 different groups of methods for this, uh, which is basically filtering or embedded method. But one solution that can be considered is what we call sparse solution.
Okay, sparse
So,
solution.
yeah, so in this method, sparse solution, the selection of the variable is done automatically within the method. Okay, so it is
Mhm.
done automatically with the method. So we need to formulate the method in such a way that it would produce a variable selection effect in the modeling a solution. Okay, so that the variable selection is done automatically within the method. There is no two-stage, like in filtering there are 2 stages. We identify the variable first, which one that we
Yes,
want to select and which one that we want to leave out, and then those who are selected put in the modeling. Okay,
together.
but in sparse solution method, what happened is that we put all the variables into the model. Okay, but
Okay,
when we fit the model, an automatic variable selection take place during the iteration, such that this will only identify a certain group of variables uh, to be considered significant. Okay. That way, the variable selection happens automatically within the modeling formulation.
okay. We have a good question here in the chat. It's from Arwa. She said, "What about the unbiased in data set?
Unbalanced,
Yeah, unbalanced in the data in
unbalanced data set. I don't understand what this means as unbalanced. If we if this unbalancedness is referring to the grouping that is unbalanced, yeah, there are some methods that people have investigated. Yeah, this is usually common in the context of fraud detection. Yeah, so in fraud detection, imagine if you have 1 million transaction. banking transaction, 1 million say, or probably 10 million banking transaction. What happened is that among that 10 million transaction, there may be around 100 transactions that are considered fraudulent. Fraudulent means, related to fraud, yeah,
Okay.
criminal activity. Okay.
Okay.
So when
Thank you,
there is an
Doctor.
unbalance like this, what happens is that any machine learning method that you use will have 99.99% accuracy, even if the model
Yeah.
is just doing this.
Yeah.
Do you understand? Because I just predicted it's not fraud, and then you have 99.99% accuracy. Because the number of
What is too low?
fraudulent transaction is small. So
Yeah.
what people have done so far is by considering selective sampling. Yeah. So for example, if we have 100 or 200 transactions that are considered fraudulent, then we randomly selected another 100, 200 from the banking, the normal banking activities, transactions, and then we put it in the model. Okay. We also have some studies that suggest uh, um, magnifying, amplifying so we increase the number of fraudulent activities in the data to be comparable with resampling, of course, to be comparable with the normal transaction data. So those are generally the one of the approaches that people use to check the how the model can deal with the unbalanced data.
Okay, I think we will never stop if we continue asking questions because there is too many questions in the mind, and inshallah we will put a thread or we will talk about the spread solution inshallah in our Twitter account. So remember to follow the global data community, and we will talk about it inshallah soon. So let's back to the session. Dr. Arif, you have long experience in too many fields, like you said, the biostatistics and GIS data and another field. But today you picked a business field to talk about. Tell me, why you picked a business?
I'm not an expert in business per se, in the sense that I'm not really, my background is not in business. However, this is just an interest of mine.
Mm-hmm.
And the reason for this interest is because I used to be a program manager for MSc Data Science and Analytics in the University of Leeds. So when I was a program manager, this program is a collaboration between 5 different schools: School of Mathematics, School of Computer Science, School of Geography, School of Medicine, and School of Business, so business school. So naturally, I also study the modules that they give in the business school. And this is where it became an interest of mine, how some data science method are considered in a business setting. Yeah. So this is generally because of an interest of mine. I know what's going on in a real situation in business. Is because I also have some friends who work in business, and they also share with me their problem. Although I cannot show it to you because it's confidential.
Oh,
But I discuss with some of my friends who also work in business, and they show me, look, Arif, this is the problem that we have. We want to check whether this group of customer is going to be able to pay back the credit or not, etc. So it's a discussion that I have had with my colleagues, and it's just a personal interest of mine how data science methods and analytical methods are employed, are used in a business context.
Okay, thank you, Dr. Arif. Can you start with the talk anytime you are ready?
Yeah. Is it okay if I share the screen now? Yeah.
Yes, I give you the permission. I think you can now.
Can you see my?
Yes, clear.
Yeah. Okay. Uh, right. So today I will talk about big data analytics and business competition. One moment. Right. So, well, this is basically about me. I did my PhD in biostatistics in 2004 in Karolinska Institute in Sweden. And then I moved to UK as a postdoc in Medical Research Council. And since 2007, I've been a member of staff in the Department of Statistics, University of Leeds. And I'm a manager for MSc Data Science Analytics program for about 4 years. Yeah. The purpose of this talk is to highlight the importance of big data analytics, yeah, in business competition and how to prepare for it. Yeah. Allow me to discuss a little bit about Industry 4.0. So what happened is that we actually are in the period of Industry 4.0. The first industrial revolution happened in the 18th, 19th century with the discovery of steam engine. So what happened here is that all this work that were done by human being or animal at that time started to be done with engine. So there is a energy revolution here where we have a mechanization of process in the manufacturing and other processes. And in the second industrial revolution, what happened is that we discovered electricity and manufacturing process that focus on mass production, meaning the production for masses, kind of like a car used to be made by 5-6 different people by finishing one car and then until from start to finish and then sell it. But with mass production, we are talking about one person doing only one particular job within a production chain. Yeah. And the third industrial revolution happened in 1980s with, well, it's in smaller scale. It happens in the 70s with the discovery of, or the invention of computer, so that the automation of a manufacturing process took place. We learn about robots and things like that. And in the fourth industrial revolution, which we are at the moment experiencing, we are talking about cyber physical system where this automation between gadgets, yeah, between robots or between devices they are made wireless and interconnected such that they can quote unquote talk to each other. Yeah, this machine can talk to each other. So this is the, well, an example of this would be your mobile phone. Okay, imagine 20, 30 years ago, to gather people in one event, yeah, you need to send letters or ask someone to go on knocking on different people's house. Now you just send a message through WhatsApp group, and that's it. People can gather. Yeah, and that's just basically communication between gadgets. Yeah. So in this industry revolution 4.0 is marked by the emergence of big data. Okay, which I will cover in the next slide. The communication between your mobile phone, for example, this is an example of big data that happen in a big scale between people. Imagine if it's, we are talking about a country or a continent, or for the whole world. Yeah, we are talking such a big data that constantly interacting between gadgets. Yeah, and it's on everything, basically, virtually everything. So this kind of data needs special handling, and this is beyond Microsoft Excel. Special database method is needed. And this big data is the lifeblood of Industry 4.0. Yeah, lifeblood means that's basically what's keeping Industry 4.0 thrive. Okay, that they are developing at the moment simply because what happened underneath this Industry 4.0 is the exchange of data between gadgets. Yeah, that is why some people say that big data is Industry 4.0. So that this Industry 4.0 is basically data revolution. So these are the 4 V's of big data that we can see. We're talking about volume of the data. Yeah. Now, terabytes, gigabytes of data is not something unusual to be found. Yeah, in even at home. Okay, in at home, if you record some movies from Netflix, for example, one movies we are talking about 2-3 gigabyte of data. Okay, it's just a single movie. Okay, so that's quite massive. Yeah, imagine if we are talking about a company or at nationwide scale, what what kind of size or memory are we talking about there? Yeah. Secondly, is the velocity, meaning the speed. We are talking about data that are constantly uh, being generated, including our webinar now, because it's using YouTube. Basically, we are streaming data through the internet in YouTube. Thirdly is variety. So we are talking about different types of data, not only text data, yeah, but also uh, streaming data, video, voice data, data that's from sensor, but also data that are inputted from uh, web page and social media platform. Yeah, that's the type of variety of different forms of data. And lastly is veracity. There are some uncertainty in the quality of the data, and this is quite serious, including that some data may be, although they are big, the information contained in the data may be small in a certain parts of the data, so to say. So it is possible that the data, the information contained in the data is actually uh, contained in some number of variables only, not all of them. Okay. So we have talked about big data. How about business competition? Well, business competition it's all about staying ahead. Yeah, we are talking about rivalry, yeah, between companies or between business entities. For example, when they have similar products or they have the same target audience. So basically, they are competing for that. Yeah. So what they want to get is more sales. Yeah, more sales, more revenue, and more market share. So how to stay ahead then, if that's the case? Well, we can improve or optimize business operation. Yeah, so increasing the efficiency and reducing waste. So, for example, if we can make a process more efficient, then it's less cost, faster, good value for money. Yeah. Also, identify and address your customers' pains, needs, and aspiration. So this is important. I was giving a talk in front of some business leaders some times ago, and one of them asked that now to have a sale is very difficult, but it's not necessarily because what they do is wrong, but because it is possible that their customers may have changed uh, style or change preference, but the business doesn't realize that. Yeah? So it is possible to identify that, and once you identify that, you can address, and that way you can stay ahead in the competition. And lastly, it's about innovate, and this is obvious because without innovation, then you're just going to stuck and you're not going to stay ahead. One thing to note is that when we innovate, this is a continuing process. So it's not really just one innovation and stop. Yeah. So big data analytics, when we talk about business competition, this is essential. Okay, to stay ahead. Big data analytics are not just an accessory, so to say, in business. It's essential. You need it. You must have it to stay ahead in the competition. So this is the list of uh, top companies in terms of market value. Okay, on the right side here, this was the list of big companies in the world in 2008. In the left here, this is the list of companies, the big companies in the world in 2018. Yeah, you notice that there is only 10-year gap between them. Yeah, I'm not talking about 20 years, I'm not talking about 30 years, I'm just talking only about 10 years. We can see here in 2008, the list, the top big companies in the world are dominated by energy companies. Okay, PetroChina, Exxon, yeah, and then Gazprom, Royal Dutch Shell, yeah. There's a telecommunication company here, yeah, and Microsoft here. But generally speaking, energy companies and utilities companies tend to dominate. But just 10 years later, in 2018, look who are in the top 10 in companies. Apple, Google, Microsoft, Amazon, Facebook, Tencent. This is also like a Google in China. Yeah, Alibaba, also like Amazon in China. So this 1, 2, 3, 4, 5, 6, 7, 7 out of 10 companies, they are the one who deal with big data analytics. Okay, so big data analytics are essential to stay ahead in the competition. This is the indication of it. So I want to discuss a little bit about some case studies in this. There's a book called Big Data in Practice, yeah, by Bernard Marr. So this is a good author. He talked about how 45 successful companies use big data to deliver extraordinary results. Yeah? So I'm going to pick 3 of them from this book. Yeah. The first case is Amazon. Yeah. In Amazon, they use predictive analytics to get 360-degree view of consumers. Yeah. So they want to understand their customers, their background, what they think, how they behave, so to say, and how they would respond to any, I don't know, to any marketing campaign or anything like that. But here's with that, it comes with a problem. Okay. So what do you think is the problem here? Well, the problem is that online retailers like Amazon, they have a large selection of products or services. Okay. They have books, clothes, electronic devices, laptops, mobile phones, whatever. You name it. Anything that you can think of, Amazon probably sell it. Okay. So they have a large selection of products. Yeah. Well, natural, because they want to increase the probability of making sales. But the danger here is that there's an information overload. Information overload means there is a danger if you want to sell too many products, too many services, you want to put too many information on the computer screen, it becomes information overload. So it can be overwhelming for the consumers. Yeah. And psychologically, it can lead to what we call buyer's remorse. Yeah. I don't know whether you're familiar with this term. Buyer's remorse means some buyers may buy a lot of selection of products, but because they don't need it, they regret it in the end. Okay. Once they regret it, that's it. They don't want to have any experience with this company again. Okay. So if you have information overload, your customer may buy, I don't know, 5,000 real worth of items, but it's only in the first month, because in the second month they may feel, oh, I regret buying this, I don't want to buy anymore. So they are not buying from the company anymore. So what happened is that when we talk about lifetime value of a customer, so this is a concept that we use in business and economy. Lifetime value of a customer, in 1 year, we only have 5,000, the company only get 5,000 real from this consumer. But if there is no information overload, and Amazon can make prediction on what item do we actually need, the customer only may buying only 1,000 or 2,000 real worth of items. But because they are happy with their purchase, they will come back again to Amazon the next month, and then come back again to buy other things that they need. So what happened here is, from company's perspective, rather than getting 5,000 real in the first month but nothing after that, so the company would rather get only 1,000 or 2,000 real, but the customer keep buying from them in the long run. Okay. And then 1,000 real the next month, another 1,000 real in the next month, etc. So overall, in 1 year, that customer may eventually spending 10,000, 20,000 real in a year from this company. Yeah. So if you are thinking from the from Amazon's point of view, naturally you will think about the second case, where the customer may be buying 1,000, 2,000 real in the first month, but they keep coming and coming again because they are satisfied. So to be able to show this, so Amazon has a predictive analytics, and they use historical and other customers' data to predict what we need. Okay, so for example, this is when I'm opening big data, the book about big data in practice in Amazon. So Amazon also give recommendation, okay, related to items you have viewed. So the Amazon gives a recommendation. So this makes sure that there is no information overload, and the consumer only focus on the items that they really need. Yeah. And here in the bottom part of this image, this is bestsellers in sports and outdoors. This is based on other customers' purchase in the period of that month. This happened to be in summer. Okay, when I pick up this image. So this is the solution, the predictive analytics to avoid information overload. So this way, they also enable what we call targeted marketing. Yeah. So they only send marketing to the right people at the right time on the right product. Okay. So they're competing with Google and Facebook in this case. Yeah. So the result of this is that Amazon has become the largest online retailers in the US. Yeah. Because they focus on the customer for recommendation. Yeah. So they are now recognized globally. For the second case is Walmart. Yeah. So Walmart, I don't know whether some of you are familiar with Walmart. Walmart is a big supermarket chain in the US. So the big data is used to drive supermarket performance in this case. So this is a big company with 2 million employees, 20,000 stores in 28 countries. Yeah. So they sell millions of products to millions of customers. This is a big supermarket chain. Yeah. So the problem is this. The problem is that they are in direct competition with retailers. So it's if you see a Walmart shop, you may see another shop nearby. Yeah. So imagine if you are a customer, if you want to buy, I don't know, if you want to buy a computer keyboard, okay, you have a choice. Okay, if I come to a computer shop, I can only buy things that are related to computer. Okay, but if I come to Walmart, they also sell computer keyboard there. At the same time, they also sell other items that I might need. Okay, so Walmart is trying to give a good option such that people can come to their shops. Yeah. So to do that, there is a logistical problem because they want to put the right product at the right time to the right people. Yeah. So the data used by them is transactional data. So they have 200 billion rows from just the last few weeks. Now here's the thing. They also, in addition to the transactional data, they also have 200 other data sources. Yeah. Meteorological data, economic data, telecoms data, social media data, gas prices, yeah, database of events, for example. Why do you think Walmart need them? Well, it's simple. If the meteorological data suggests that in an area there will be some snow in the next few weeks, okay, it gives a warning to Walmart to provide boots, jacket, and other things that people may need for snow, to deal with snow, with the weather. The same as economic data or telecoms data, social media data. They will check the social media and check any trend in a certain area. For example, if there is an event is going to take place, like a music concert, for example, that will take place in a city, this will go high in social media, and this will give Walmart a warning beforehand to I don't know, to outsource items related to that event, yeah, to that music concert, so that they can sell it in Walmart. Yeah, they also use customer loyalty data. Yeah, so when they combine all these different data into their analytics, uh, the results that they take is that uh, Walmart pharmacies are more efficient. So inside Walmart stores, they have a section on pharmacies. Based on the big data analytics, they can make prediction what is the busiest times in the day. Is it in the morning, during the day, during lunchtime, or in the afternoon, or during the night, or which day in a month? Is it always Saturday or Sunday or weekdays as well, or which month in a year? So these help them with staff scheduling. Okay. They also use this big data to manage steps of supply chain, yeah, to optimize routes, to get the transportation cost down. If they know certain items in a certain warehouses need to be transported to certain stores, they will optimize the route such a way to keep the transportation cost down. Yeah. They also optimize product assortment. So what are selling or about to sell? Yeah. I don't know whether you realize this. I know that in Saudi Arabia you don't have uh, a wide range of alcoholic products in supermarket, but there in the US they sell beer in Walmart. Okay, but the thing is, next to the next to the beer section in the store, they always have uh, Pampers, like nappies, baby nappies. I don't know whether you know this. Nappies that you put on a babies. Yeah,
Yeah.
yeah. So why do you think that? Because they have data that shows that the sales of beer is correlated with the sale of baby nappies. Yeah, it doesn't make sense to you and I probably, but if you go back to the data, you will learn that you see in the US, people they go to the bar usually, or pub bar. I don't know. What do you know this bar? Like a shop that sell alcoholic drinks, where they hang out with friends in the bar, where they drink beer and alcohol. However, when you are married and start having little kids, you don't go to the bar because you are staying home more frequently to babysit the baby, but you still want to drink beer. So when you buy beer in the supermarket to be consumed at home, you also look for baby nappies because you have babies generally. That those people who buy beer in supermarket, they tend to have babies as well at home. That's why from the data they can see that. Yeah,
Yeah, I remember some weird correlation, something like this.
yeah. So this is something.
In a place there is a tornado. They like to have some kind of candy, I think, or something like that.
Yeah, so this is
So
an example where the data can optimize product assortment in a shop, and also it can have a personalized shopping experience, because what happened here is that you can have a discount based on historical purchase. Okay, so if you buy a keyboard from Walmart, and the Walmart has the data on you on that. They will send an email to you that, oh, by the way, if you use this coupon to buy computer mouse, you can get a 30% saving. It's because they see you that you bought a keyboard before. When you have a keyboard but you didn't buy the mouse, the Walmart trying to remind you that, oh, you may be needing a mouse, a computer mouse. And by the way, we also can give you a discount. Okay, so it's a personalized shopping experience. And lastly, this is quite interesting, is that you have a fast troubleshooting here because you monitor the transaction in real time. Yeah, we can the store can perform a troubleshooting within 2 and 3 weeks. Sorry, previously 2 to 3 weeks to just 20 minutes. Okay, in troubleshooting, for example, suddenly you see that some items are selling very fast, out of ordinary, and then you check that, oh, there was a mistake in the pricing. The item that supposed to sell for 100 rial, it was mistakenly put only 1 rial. That's why it's fast selling. So with this, you can spot it within 20 minutes rather than 2 or 3 weeks before the big data analytics were introduced. Okay. The third case is about General Electric, or GE. Okay, so this is a big company in the US that deal with aviation. You know, kind of like a plane engine. Yeah, manufacturing, healthcare, energy production. Yeah, so if you generating electricity from wind, they make the turbine for that. So the problem here, okay, in this particular context, is how to keep the machinery and system running efficiently. Okay, that's the thing. Imagine if you fly in an aeroplane, you want to fly where the system, the engine, is running optimally. Because if it's not running optimally, there is a danger. The plane will not be running. You know, imagine if you want to fly from Riyadh to Jeddah, then it's supposed to be just 1 hour, and it takes 3 hours. Then it's, or even not arriving at all. That's dangerous because
That's worse.
that's the machine is not performing to its best capacity. Yeah, so it has an implication on running cost, safety, of course, and if there is a downtime means the machine, the engine is not used because it needs a service. During the engine is being serviced, the company, the, I don't know, Saudia or Flynas, is not able to generate money from that. Yeah, so that's a loss of revenue. Yeah, so the data used in to this effect is to have the sensors on board of the machines and the system. Yeah, and then they monitor the operation. Some of them in real time, meaning that if you fly with the aeroplane, you don't realize this, but the the engine of the aeroplane is actually generating data, and the data is transmitted to the satellite in a real time as you fly. And then the server of GE will pick up the signal whether the engine is running optimally or not. Yeah. So this could estimate a scheduled maintenance. Yeah. And the result for this is that um, the customers can expect a saving of $8 million from reduction in downtime per year. Yeah, so that's the results. So the customer can save 300 billion US dollar for 1% increase in efficiency. Can you imagine that? Just 1% increase in efficiency will save the customer in total 300 billion US dollars. So this is something that they really focus on with big data analytics. So you may think, well, those are big companies. So if I have a small company, will it work? Well, the answer is yes. So there's an ice cream shop here in Leeds, increases their revenue by just collecting data on social media and also the sales for the sales that they have. So what ice cream is sold at what time, by how much, and they also record this ice cream shop record whether today is raining or not, whether today is hot or not, etc. So this data were analyzed and they managed to be able to increase their revenue as a result for this. A restaurant in Boston in the US.
Excuse me, doctor, but I have a question here.
Yeah.
About small company, I think we call them a small company because they have a small budget.
Yeah.
So and investing in big data will cost a lot. So what can they do?
Well, for big companies, yeah, because they can have their own department on data science or data analytics. They can have their own servers. They can have their own people to analyze the data for them, which is okay, yeah, because they need it. They need those people. Of course, it will cost money.
Yeah,
But
a
for small
lot.
businesses, there are several solutions that they can use. There are several apps or software that they can use, and they can use cloud services, yeah, which allows them to store or to check to store the information or the data and perform analytics in the server in the cloud. So this will save money and it will not cost a lot. So this is what happened with the Boston restaurant case here, because they use cloud-based software to perform a data analytics on their sales data, yeah, which increase their revenue. Okay, so also in the last case here, a butcher, yeah, a shop that sells meat in North London increases their revenue because they install a camera in front of in front window and analyze the data, and they can check what works and what doesn't. So in the end, they manage to diversify the business. So they don't only sell meat, but also sell food, like cooked food. Yeah. However, there's always a challenge in adopting big
So,
data
Doctor,
analytics.
the solution in the big data analytics is not always having a department and having a data scientist and having a big solution. There is a
No.
small solution for small businesses.
Yeah, there's always a proportional solution in this case. Okay, so if for a small business, then you don't need uh, a special data science department in your business, so to say. There are many ways that you can perform big data analytics and for a small company, and you can use cloud-based software to perform the big data analytics. So the challenge here generally for adopting big data analytics is, first of all, is problem identification skills. Okay, because the problem is not always visible. Statistical thinking is critical. I already talked about this in February in Riyadh about this about statistical thinking in big data analytics, and it's a skill that we need to think about. Yeah, ICT knowledge and infrastructure. Yeah, because storage, network, cloud, and analytic platforms may not necessarily be appropriate for different types of businesses or different types of companies. So there's always a room for improvement for this infrastructure. What data to record? Yeah, possibly all. I don't know. So this is something that business can consult the statisticians. And lastly, of course, data governance and legal aspects. Yeah. But one thing to note here is that whatever that is, data science is a collaborative effort, okay, in terms of area of skills and knowledge to consider. So this is a Venn diagram from Drew Conway that I don't agree 100% with this, but for the purpose of this explanation, I think this is sufficient. Is that data science is an intersection there between mathematics, statistics knowledge, between computer science skills, and substantive expertise. Substantive expertise here in the context of business, then the business knowledge, yeah, that we have. So data science is actually in the middle there. So it needs a collaboration in a way from three different parts for data science to be successful. How to prepare for big data analytics for your business competing in business? Well, big data analytics aim to solve a problem, yeah, but not all problems are solvable with big data analytics. For example, if the problem is in the management or in the, I don't know, the characteristics of the people handling the or managing the situation, then it's difficult, because big data analytics aim to solve a problem that is quote unquote objective, yeah, that can be put into data. So identification of problem is critical. The key here to prepare for big data analytics is to follow the data or follow the information, because everything is data here. So customers' preference, need, aspiration, ideas or thinking, you need to follow them. Yeah, whoever the customer is. Your customer might be another business, or your customer is the public. Yeah. For example, and this is just an example, online transportation service. Yeah, you have Karim or Uber. Basically, the app that they have is they're trying to follow the data from your mind. Okay, because if you want to get Uber or Karim, basically you already have an idea in mind. I want to go from here to, I don't know, company A in this street, in Ulaya Street, say. Yeah. So you already have what route to have, how to get there, how long will it take usually. So when you open Karim or Uber, you technically translating the information from your mind to the gadget in terms of data that the gadget, your mobile phone, is able to process, yeah, that information and connect you directly to other people. In this case, Uber driver or Karim driver, to come to collect you and bring you to your destination. So follow the data is the key here. So if you want to have a big data solution for your problem, then the first question you can ask yourself is where the data is where the data is located and where the data should go. Okay, and what kind of information should go out from that data. In terms of infrastructure, then space and handling of data, hardware and software, this is the usual stuff for ICT infrastructure. But the last thing that I want to highlight here is that that infrastructure should be scalable, okay? Because if your company growing, then the big data analytics platform should grow, or the infrastructure should grow with that as well. Lastly, to prepare is for you to have a statistical thinking, about the analytical methods, because big data analytics will produce results, and the interpretation of the results is vital here. Because when you have data and then analyze the data, this data will become a result, a knowledge, and this knowledge should inform you about any insight about what's going on there. Because once you get an insight, then you can turn insight into action. Okay, a decision by a decision maker, by the company or by the people who is handling the problem, to decide or to take action. Okay.
Okay, here, Professor, sorry, but
Okay.
in this second part, analytics methods and big data analytics and all this you have said, that mean we all have to be statistician to be prepared.
Well,
Is
you don't
that
have to be. You don't have to be a statistician. Okay, you can have a statistical thinking. That's the most important thing. You don't have to be a statistician here. Uh, the statistical thinking means you understand the principle behind the method. Yeah, you understand what assumptions that it has, and then you understand how to interpret the result afterwards. I think that kind of skill is required to be built, and it's easier to build that skills if you have a statistical thinking. So there's a difference of being a statistician and to have a statistical thinking. You don't have to be a statistician to have a statistical thinking. This is something that you can learn. And I think this is the last
okay?
slide.
That's good news. So everyone can be prepared, and he don't have to study all the statistics
Well, you
methods.
need to study statistics, but the principle behind it only. You don't have to understand what a random variable is or how to prove this and that. You don't need that. You don't have to go down into the theory behind it, but you need to have a thinking, a principle of the statistical methods that you are dealing with.
Yeah. Thank you.
So this is the last slide, I think. Bill Schmarzo in 2016 described the stages of business adoption on big data analytics. So this these are the stages, that the big data can be part of the business that you have. Going from the left there, business monitoring, this means that, well, the data in your business is just collected and you just want to check whether everything goes okay. And that's it. So that's basically business monitoring. But if you can go to business insights, which is the next stage, means that if you apply data science to that data about your customer, about your operation, about your product, you can uncover insight. You get insight on what's going on and trying to predict business outcome. Okay, so for example, if this is the case, if this is the customer, then we can predict that the next month we will have a certain number of sales, etc. So we are already, this means that we look into the insights based on the customer data or operational data. Thirdly, when we talk about business optimization, then this is where the data can help you to save money in terms of increasing efficiency, reducing waste, and optimizing your business. Okay, so if you, from the data, if you can identify, well, like Walmart case, where optimizing the logistic chain save the money, or in the case of GE, optimizing the performance of the engine will save the customer money because of that. And the next stage, the fourth stage, is insight monetization. This is where after you optimize your business, you are able to identify other products that would sell along with the 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 business that you have. Meaning there is a possibility to grow the business, yeah, because you start making extra money, so to say, from this data, not only from the business that you have done, but also other areas. Yeah. And lastly, this is the metamorphosis. This is where the whole business become transformed. Just like Amazon, it becomes aware everything is data. The way the business is done is efficient. The way the customer service is done is efficient. The way that they open new areas to sell becomes a money making, etc. And also they have a digital transformation, yeah, to make the growth even higher. Yeah, that's why now Amazon has different programs where you as an individual can actually sell a product through Amazon in the US, and you can sit down in your home without leaving your room. Do you know that? You can contact a business in China that produce something, yeah, an item. You can connect to Amazon. You can ask the business in China to ship to an address in the UK, for example, and then the Amazon here will sell it for you. So you can actually make money without leaving your room. Okay, that's possible. So a different business mode is possible. So I think that's the last slide. Thank you very much for your attention. Yeah. So I'll stop sharing.
Thank you very much, Professor. That was a great talk. And now this is the part where is everyone can ask a question. So this is your chance. And I think we have here a question from the YouTube.
Yeah.
He's from Bassam. He's asking about is it better to have it's a long question, but the short one, I think he's asking is it better to have an expert or having okay, or one expert and he's taking your data and analyze it, or going with a company that can analyzing your data. I think, and there is another option, whereas you can have a tool and take the feature that you need.
Right. I'm not entirely sure that I understand the question, but if I can try to make sense of it, whether someone analyze your data or a company analyze data is actually a personal preference. Okay. Who analyze the data is not important, but make sure they know what they're doing, whatever that is, whether it's a company or a person or whatever. I think if they know what they're doing, that's fine. That's the most important thing, because at the end of the day, the results of that analysis will come back to you. And if they cannot make sense of it, you will not be able to make sense of it as well. So that's the challenge. Okay. So make sure that you are dealing with the right partner, the right person, or the right company on that. I hope that can answer the question.
And how can you pick the feature that you need? Sometimes there is a features you don't know about it, but you need it. You are not an expert, but how can you know which features are the best for you if you
Well,
need to go with the
that is
solution?
the beauty of, well, in fact, it's the challenge and the beauty at the same time of variable selection. So variable selection aims to to have the data informing us which feature is important, okay, rather than selecting a feature based on subjective belief. Like subjective belief means we feel that a particular feature is important, so we just put it in the model whether it's important or not, okay. So that is a subjective belief. But if we want to be objective, then variable selection uh, is a challenge in many areas. And the problem with variable selection is really in the correlation between the variables. That's where that's the biggest challenge, because what happens is that you don't how to make sense that in a group of variables, when they are correlated, that whether all of them are important or only some of them important. Okay. Well, naturally, if they are correlated, then all of them carry the same information and they should be selected uh, together. Uh, but some selection methods are not able to deal with this. That's a challenge.
Okay, thank you, Prof. There is another question from your expertise. If someone wants to go deep in data science, what should he do?
It depends on your background. Yeah, if your background, because it's collaboration of three different areas or three different fields between statistics, computer science, and substantive expertise. Then, if you're coming from statistics background, yeah, then you need to acquire skills and knowledge from computer science, yeah, as well as the substantive expertise. Like if it's business, then you need to learn a little bit about business, what's going on in business area. If you are a computer scientist, yeah, if then learn a little bit about statistics, the principle behind it, and also the subjective expertise like the business or any other areas. I think that's pretty much the underlying message that we have if you want to master data science. Yeah.
Guys in the Zoom, you can ask your question in the Q&A. It will be better than write it in the chat. So if you have any question, just write it in the Q&A. Okay. Yeah, there is another question here. It's about what's the difference between time series and regression? They are all
Well,
prediction the future.
yeah. Time series is basically a series of data over time, uh, and the connection with linear regression is that you can estimate time series parameters by putting it in a regression context. Okay, I'm not able to describe this in a technical way in this webinar, but you can identify the answer to this question if you Google it. Yeah, connection between time series and regression. So linear regression deals with a pair of variable in the simplest sense. Yeah, a pair of variable, an outcome variable, and a predictor. And we assume a linearity of effect, yeah, so to say, between the outcome variable and the predictor. That way, if the model is satisfactory, you can make a prediction. For example, if uh, you have a house that has a certain number of bedrooms, certain numbers of areas, how much would it cost to sell? Yeah, in terms of selling price. A simple question or prediction like that can be done if the model is satisfactory in linear regression. Yeah.
Okay, there is another question about the assumption. Should we study the assumption in case of big data?
Yes, the assumption is actually for the method in general. So any method that you consider, they usually assume something. Yeah. Okay. So for the data, you can observe them. You don't need to assume them. For example, if the data are correlated, then you don't say I assume that the data is correlated, because you can actually see whether the data is correlated or not. But the assumption tends to be associated with the method. For example, in linear regression, then the assumption is that it's additive, meaning that the effect that you have, the predictor, they add to the prediction in an additive way. Yeah. The second assumption, for example, for linear regression, is they have a constant variance of error. Yeah. So that's the underlying assumption for linear regression. And the last one is that the residuals, or the the error term, is assumed to follow a normal distribution. Okay, so when you interpret the results later on, then you have to keep this in mind to make the interpretation to be sensible. Yeah.
Yeah, we have a question here in the Q&A. How can we reach the perspective analysis and the tools?
Well, for perspective analytics and tools, some publicly available software like R, yeah, or Python, they usually have libraries or packages that provide functionalities for analysis, yeah, of prescriptive analysis. Yeah. So there are thousands available R packages that you can use. Uh, Sorry, that you can check, and some of them might be useful uh, for your analysis. So uh, just look for public domain, public repositories like R, Python, and any other publicly available software. They usually tend to provide specific packages for a specific analysis that might be useful for you. Yeah.
Okay, there is a good question from Arwa. She said, which area in the future do you think the analysis focusing would be? Is it in bio
Uh,
or in images or what?
well, almost all areas, okay, almost all areas are going to be impacted by big data analytics. So there will be, if you think that in the business, what we discussed today is enough, no, we just deal with the with with the uh, with a very small topic in the business, in the application of big data in business. You can think about survey data in business, for example. If a company would like to market their product to people in Riyadh, what would they need to do? Okay, so we need a market research analytics in this particular context. And if the same company wants to sell the same thing in other cities, should they use the same approach? Well, maybe not, because customer in Dahran, in Riyadh, they may have a different characteristic than people from Hijaz area, like from Jeddah, from Tabuk, from I don't know, Taif and other areas, from Makkah, Madinah. They may have a different characteristics in terms of their tendencies to buy. Okay, so this type of thing needs to be consulted with data science and analytics to make sense on what the company should do to market their product. Yeah.
Okay, there is another question. How we can start in data science?
Well, for data science, I think you can start from well, depend on the people. Yeah. So if you already are in university, then if your area of study is related already to data science, then that's fine. But if your area of study is far away from data science, then you can take some training or reading some books, or I don't know, learn from some workshops or seminars and things like that about data science. And as I said, data science is a collaboration between three areas. So make sure that you have the computer science skills, statistical skills, and the substantive expertise on that. Yeah.
Okay, there is too many questions, but the time is limited, so we will have the last one. So here there's a question. Okay, do you prefer deep learning or machine learning to analyze problems?
Well, deep learning is just a method within a machine learning topic. Yeah. So deep learning basically is just a neural network with so many hidden layers in it, such that they allow a deeper investigation at different layers. Yeah. So basically, deep learning is a method of machine learning. So usually when the problem is very complex, now deep learning may be needed because they allow a different investigation at different layers. Yeah.
So do you prefer using it, or you think it's just
Well, it depends on the problem. If the problem is quite complex, then we need to you may need a complex method to deal with that. But if you have a simple problem, why you need a complex method? It's like overshooting, if you know what I mean. If you want to kill a mouse, then you use
shotgun?
a simple thing. You don't kill a mouse by a dynamite or anything. You will blow the house. The mouse
Okay.
it will die, of course, but also the house that you're staying in.
And dynamite will cost you a lot.
Yeah,
Okay.
yeah.
Okay, thank you very much, Dr. Arif. But before we ending this, do you have anything to add?
I remember what to add before, but I don't know. I forgot about it now. So maybe no.
Thank you very much, Dr. Arif. That was a great talk. Thank you.
Thank you very much, for
Yeah,
inviting me.
we would like to thank you very much about everything you have done. This great talk and your time, and we would like to thank the community for attending here at the Zoom and in the YouTube. And thank you. And we would like to thank also our sponsors, Masterworks and Serene and the CAS Center for sponsoring the data communities. And see you soon, Dr. Arif.
Inshallah, yeah.
Inshallah, soon we will see you in Saudi Arabia.
Back in Riyadh again, inshallah, yeah.
Inshallah. See you, inshallah. And
Inshallah.
assalamu alaikum wa rahmatullahi wa barakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.